One thing about math, you never know when a problem will be hard or when it will be easy. So I'm going to go ahead and show you the steps for this one problem that has 4 different parts. All right, orbital speed. This is a diagram of the Earth and the satellites that surround the Earth. If you look closer to the Earth, you have the scientific satellite going in this direction. If you look farther from the Earth, you have the GPS that's farther. And with problem number 4, this information is going to help us out a lot. I'm about to darken up the colors a little bit. Now let's do number 1. We have the GPS satellite that travels 23 over 30 kilometers per second. Let's figure out the rate by dividing. We're going to go in the direction of x, 23 times 5. And I'm going to write it like this because this is more complex. Over 30. I don't have to do the times 1 because of the fact that any number times 1 is itself. Now, I have 23 times 5. I can easily do that and get 115. But why do that when I know that 5 can be divided evenly into 30? I know that it takes 6 5s to give me 30. That means I keep the 23 on the top. The 5 will turn into a 1. I don't have to write the 1 while I'm multiplying. And I'm going to put a 6 on the bottom. So our rate will be 23 kilometers per second. But notice, they don't want us to find just the rate. They want us to see how far the satellite can travel in 12 seconds. That means I'm going to take this first part and I'm going to do 23 over 6 kilometers times 12 seconds. The S's, they cancel out because you got an S on the top and an S on the bottom. And since 2 6s fit into 12, I can change this into 1, change this into 2. So 23 times 2 is 46. And since kilometer is the only word that I have left, there you go, my final answer for part 1. Now, part 2. If you look at the structure of the problem, I'm going to start off doing the same thing, which is dividing 2 fractions. But things get a little bit more interesting. We're going to do this in purple. Three times 10 is 30. 1 times 4 is 4. From a previous problem, I did show that 30 divided by 4 is 7.5. And you can also use a calculator on your own time. So since I was dividing kilometers by seconds, like I did in the last problem, I can just put this here. Normally, I try to avoid putting the units in the middle of solving a problem to avoid more work. I kind of go in between because if the problem get harder, I need to keep the units at every step. But in a problem like this, I could have just easily just not did that. Now, I got to see how far did it travel in 1 hour. Oops, I meant 1 minute. My apologies. That's why it's always good to go back and read. In order to do this, I will do it similarly to the last problem, 7.5 kilometers per second. And I have 1 minute. I have to ask myself, how many seconds are in a minute? 60. Cancel these out. Now, I can rewrite 7.5 times 60 as 75 times 6. When I do 75 times 6, I'm going to get this. I'll get 450. And that's my final answer for the second part. Now, 3 is just a simple question. And I'm going to try to do it like this. Maybe make it a little smaller. Okay, too small. Okay, is the orbital speed of the scientific satellite faster or slower than the GPS satellite? Explain. We're going to use the work that we did. All right. The orbital speed of the scientific satellite is faster because 7.5 kilometers per second is greater than 3.8333 kilometers per second. That's why the scientific is faster. And I'm going to give you details of how I got that 3.8333 kilometers per second. I put the to show that the threes are repeating. So let me do a little bit of work. Let's go back to number 1 when I got 23 over 6 as my answer. 23 over 6. There are 3 6s that are fit in. Then I'm going to have a remainder of 5 because 23 minus 18 is 5 over 6. So now we're clear where the 3 point come from. And 5, 6, since I do know my decimals very well, I know that it's going to be 8.8 with the 3 repeating. That's how I got that. And that's all I had to do to answer that question. That's all I had to do for number 3. So what I'm going to do, just in case if some people couldn't see that, maybe that was too small. Yeah, maybe that was too small. What I'm going to do is zoom into this. I'm going to zoom into this so it can be easier to see. And feel free at this point of the video to give it a pause. Now, number 4. Just like number 3, it doesn't require any math. I'm surprised it's not letting me edit. Yeah, it's just like number 3. No, it's letting me edit. Okay. Now I'm going to go ahead and do a text for this one. They say the moon travels. Yeah, they say the moon travels 3,600 kilometers per hour around the Earth and is about 19 times farther from the Earth than a GPS satellite. Compare the speeds of the moon and the satellites and make a conjecture about the orbital speed of an object in relation to its distance from the Earth. Believe it or not, it's not going to require a lot of math. Now, I'm going to tell you off the bat, what we need to do is figure out what is 3,600. What is 3,600 kilometers per hour and kilometers per second. That's all we need to do for that part. Now, I have 1 hour is 3,600 seconds. Cancel out the hours and cancel out the 3,600. I'm left with 1. So notice the moon is 19 times farther than the Earth. We know that the moon is 19 times farther than the Earth. And we notice, back to this picture, not only is the moon 19 times farther than the Earth, the scientific satellite is the closest to the Earth. And it had the higher speed, as we talked about in number 3. The GPS satellite is the next closest. And then the moon is like 19 times farther. We're talking about the moon is all the way off the page somewhere. And as we get farther from the Earth, the speed gets slower. Okay? So this is your conjecture. It's a proper noun. Okay? That's it. That's all that is. That's all you need to do for that.